I'm Ken Hellevang, uh, an extension engineer and professor at North Dakota State University. And today I'm going to be covering some of the grain storage best management practices, particularly looking at the area of Southeast Asia and Vietnam. When we look at grain storage, two of the main problems that we're faced with are mold growth and insects. And on this visual, I have indicated that mold growth is related to primarily moisture and temperature. Insects are primarily related to temperature, and then the cleanliness around the storage environment. Anything that is going to be in long-term storage, we generally recommend some type of a grain protectant to try to repel the insects. That does not kill the insect, but instead repels or tries to keep the insects away from the storage. I usually present grain storage as being these three steps. We need to prepare the structure, we need to prepare the grain, and then we need to manage the stored grain. And that's going to apply for all the different types of storage environments that we might be working with. For example, on this visual, I've shown a steel grain bin, bags that might be stacked inside of a building or in individual bags that are sealed to prevent the outdoor environment from coming into that stored grain. When we look at cleaning the structure, it's important to think of all the different areas around that structure. On the left portion of the visual, we show an individual cleaning the inside of a steel grain bin. And our normal recommendation is that if you can tell what was previously in that storage, it's not clean enough for the new grain. So it requires a thorough cleaning. We also recommend cleaning around the outside of the storage because the more environment that might attract insects, the more potential for problems. And the same thing would be true if we're working inside of a building. We need to make sure that the environment inside the building is clean, that is not going to attract pests, as well as outdoors around that structure. And then if possible, we recommend also applying some type of insecticide that will, again, repel the insects. Whether we're talking a steel bin or a building, we need to think of all of the potential for primarily insect infestations that can come into that structure and try to do what we can to minimize the potential of insect infestation. When we think of preparing the grain, primarily we're referring to the grain moisture content. The condition of that grain also is going to affect storage life. So if we have grain that has kernel damage or has some other damage or stress to the grain, we can still store it, but likely we're going to be looking at a shorter storage life than if we have good quality undamaged grain. Grain moisture is so important. I'm going to focus several visuals and slides on that topic. It's important to think about the climate that we're going to be storing the grain in. And I have chosen to show uh, the climate for Vietnam. The first visual is for Ho Chi Minh City. And this visual happens to be in degrees Fahrenheit. And it shows the maximum and minimum temperature as we go through the year. And we see a fairly uniform temperature, temperatures that might be averaging around 80 degrees. And I'll show you in a little bit that temperature creates an environment very conducive for insect infestations. When we look at the relative humidity of the air on average, we're running between 60% and about 80%, with several months during the year being up close to 80% relative humidity. And that too is going to be important as we think of storing that grain. This is what was listed for the climate at Hanoi. And I'm going to focus first over on the right side of the slide, looking at the humidity. And again, we're in the 70 to 80% relative humidity range, which again is going to be very important to us. Temperature varies more than what we saw at Ho Chi Minh City, but we're still looking at very warm temperatures with daily highs ranging from about 21 degrees centigrade to about 35 degrees centigrade. So again, when we translate some of those warmer months, we're looking at temperatures averaging 90 degrees Fahrenheit or warmer. This is why that temperature is so important to us, that when we look at the growth curve for mold, what we find is the general grouping, which is called mesophiles, like medium temperatures. And this is the type of mold that will typically be associated with grain spoilage and grain storage problems. And so for a majority of the time, particularly in Southeast Asia, we're looking at temperatures that are very conducive to mold growth. So in order to control that mold growth, we're going to need to make sure that the grain moisture content is low enough or dry enough to prevent that mold growth. When we look at what type of humidity typically is associated with mold growth or fungi growth, what we find is that if the airspace around the grain kernels is at or above about 70%, that creates an environment that is damp enough for mold to grow. So when we're looking at storage management, it's important for us to think of doing what we can to keep the humidity in that storage environment to less than 70% to keep it from getting moldy. When we're working with grain, we think of what is called equilibrium moisture content to tell us how dry the grain needs to be in order to keep it under that 70% relative humidity in the air spaces. In this example, we have air at 70 degrees Fahrenheit, 60% relative humidity. And if we are working with hard red spring wheat and leave that air surrounding the kernels, they will come to an equilibrium at about 13.3% moisture. So we call that the equilibrium moisture content of 13.3%. And we use that then to determine what moisture content the grain needs to be at in order to keep that relative humidity under the 70% that is going to permit mold growth. The research has been done on most of the types of grain that we're working with, and it is available online. I have included here a table for the equilibrium moisture content for yellow corn. Again, this one is showing the temperature in degrees Fahrenheit along the side and the relative humidity of the air across the top. And so if we look at 90 degrees Fahrenheit, for example, and 60% relative humidity, those two will intersect at about 12.4% moisture content. So for air at 90 degrees and 60% relative humidity, we would expect the corn to be at about 12.4% moisture content. This is a table for the equilibrium moisture content for wheat. This one now is in degrees centigrade along the left side. Again, relative humidity across the top. So if we go with 28 degrees centigrade, 60% relative humidity, we see the two intersecting at 12.8% moisture. And we will see a little difference between the different types of cereal grains, but they will be relatively similar. If we get into the oil crops, soybeans, or sunflower seeds or canola, those will be typically at a lower moisture content. So let's look then with this information at what we would need as moisture contents to prevent that mold growth. So again, at the top of this visual, I'm showing the information that we've already looked at. And then we list some of the different types of grain, the equilibrium moisture content that would be associated with 90 degrees Fahrenheit and 60% relative humidity. And I'm using the 60% relative humidity to assure that I'm staying below that 70% relative humidity level. So if we look at barley, for example, the equilibrium moisture content is 11.5%, and the typical maximum storage moisture content that we should have for storing barley would be about 12% moisture. For canola, equilibrium moisture content, 8%, and that's the maximum moisture content that we recommend for storage. Corn, EMC at 12%, and we typically think of 12 to 13% moisture as the recommendation at these warmer temperatures. Soybeans, equilibrium moisture content, 9.6, and typically again at these warmer temperatures, the recommended maximum moisture content for storage would be 10 to 11%. And then wheat is at the bottom, 12.7% equilibrium moisture content, and we typically recommend a maximum moisture content of about 13 or maybe 13.5% moisture for long-term storage. So for storage management, what we need to think of is the grain dry enough for us to store? If it is at a moisture content higher than this recommended moisture content, then if we plan to store the grain, we really should be drying the grain to this moisture content. The other thing that we need to think about is during the storage period, if we're going to have relative humidities of 70 to 80% that is typical for Southeast Asia, then it's very important for us to separate the grain from the outdoor environment. Do whatever we can to prevent that humid air from entering the grain mass and increasing the moisture content above these recommended moisture contents. So monitoring that moisture content becomes very critical. I've shown on this visual a couple of different moisture meters. One is a handheld unit, the lower one more of a lab scale unit. Most of these meters today will automatically measure the moisture content of the grain. They'll adjust by measuring the temperature and give us a reasonably accurate value. But if there's any moisture variation within the kernel, any surface moisture on the kernel, those meters will be fooled by that moisture variation. So I really recommend measuring the moisture content, then putting that sample in a sealed container, giving it time to equilibrate to room temperature, maybe a period of 6 to 8 hours, and then checking the moisture content again to verify that we're getting an accurate moisture measurement. Since moisture becomes such a critical part of successful storage, it's imperative that we be accurately measuring that moisture content. And then, as I indicated, we need to isolate that stored grain. We need to keep pests out. We need to keep damp air out. Now, the visuals that I have on this slide in the upper left corner is an aeration fan that would typically move air through the grain bin, and there's a rodent standing in front of that fan. That rodent will carry debris and material into the storage, helping to damage that grain. So pest control becomes very important. Also, I have a picture of a grain beetle. Again, we need to be monitoring and doing what we can to assure that those beetles or other insects do not have a path into our storage environment. And then, of course, the humidity. We don't want that outside humid air to get into the grain and increase the moisture content of that stored grain. So it's critical that we cover any opening into the storage with some type of airtight cover, as shown in the bottom left picture, to assure that we're keeping that stored grain separated from pests, from damp air, other things that can lead to storage problems. Dried distillers grains are primarily similar to corn. The research that has been done indicates that we need to keep the moisture content less than 12%. And that would be similar to what we're seeing with the equilibrium moisture content and storage moisture contents that we previously talked about for corn. Flowability of DDGs are also enhanced at that lower moisture content. So another benefit of keeping the moisture content at 12% or less. The distiller's grains will absorb moisture just like other types of grain do. So it's critical that we're isolating it from the humid air. This building that is shown here, it would be critical that we prevent outside air from coming into that building. We need to really make sure if we're handling the grain in a structure like this, that we're not having damp outside air entering a dry inside environment. And then it's critical that we manage our stored grain. And I've listed a definition for manage, which is to direct with a degree of skill. We need to understand storage practices that will help make sure that we can maintain the quality of that stored grain. And we've covered some of that in this presentation. As far as managing it, it's important that we monitor that grain condition. And typically what we're monitoring for is measuring the grain temperature, measuring the grain moisture content, looking for any indications of insects or mold growth. And some of that we can do with sensors. Some of it we just need to be visually inspecting that stored grain. I recommend that we need to check that grain at least every 2 weeks. We can see a lot of changes occur if in a 3 or 4 week period. So if we're going to manage the grain, we need to find these changes that are occurring before they become problems, and allow us then to apply some management strategies. And some recommend checking weekly. I think at an absolute minimum, we need to check at least every 2 weeks. It's important then that we continue to manage the grain temperature, moisture content, and insects. With the warm environment, fairly consistent environment of Southeast Asia, likely the grain will come to temperatures in near what the outdoor temperatures average to be. And so what we're really looking for from a temperature standpoint are any indications of that temperature starting to rise, which would come from grain spoilage or insect activity. And then making sure that we're continuing to keep that grain dry. There's sensors and controllers that are available to help us monitor primarily temperatures, but they do not replace the physical checking of the grain or the management. They're a tool that help you to monitor that stored grain. I included this slide because it shows some of the large storage bags that are sometimes used for grain storage. And it's critical to note what is occurring in these long grain bags. That if we run the bags east and west. The sun shines on the south side, not on the north side of the bag, creates a temperature difference within the bag, and moisture is driven from the warm side to the cold side. So just the orientation even of these storages makes a difference. We recommend that the bag run north and south so that we have the same solar heating on the east side of the bag and on the west side. We need to be thinking of drainage. Water control in our storages becomes very important. We've talked about humidity levels. Of course, if we have any leaks in the storage, any water that is sitting around the storage, that's going to create a wet environment, which we don't want. And then we need to make sure that that grain is dry going into storage and that it stays dry. And so even with these types of storage containers, uh, the principles that we have covered are the same that we use for managing these types of storages. This brings me to the end of the presentation on some of the fundamentals of grain storage, some of the practical applications for Southeast Asia. The principles are the same, regardless of where you're storing the grain. And have focused on Southeast Asia, but if you're looking for additional information, there's a lot of information available on the internet. And if you're looking for my information, you can do a search for NDSU grain drying and storage. It's been nice visiting with you, and hopefully you found this presentation beneficial.